Well, good morning, folks. This is one of the first times I'm doing videos like this, so you let me know if this works out for us. When we left off, we were talking about confidence intervals, okay? And we had done confidence intervals when sigma was known. We had done confidence intervals when sigma was unknown. I think that's where our last class was. Sigma is unknown. In that case, we use S, right? We're going to be using a t distribution. So use S, and we're going to have a t distribution here. All right. Today, we're going to go ahead and we're going to talk about confidence intervals. Okay, I'm going to go ahead and just abbreviate that with a CI from now on, because otherwise, me writing this video is going to be too long. We're going to do confidence intervals with proportions. Okay, so what kind of a problem does that look like? That looks like our point estimate would be 4 out of 5 dentists prefer Acme toothbrush or Acme toothpaste. Okay, that's not really what we're looking for here. It's 80%, or really what we're going to be dealing with is 0.8 of dentists. The proportion of dentists that prefer Acme toothpaste is going to be 0.8. That's our point estimate. Okay, this is our point estimate. All right. Remember that confidence intervals talk about a point estimate plus or minus a margin of error. So really what we're going to be dealing with here is we're going to say 0.8 plus or minus 0.025 for say, okay. The proportion of dentists that prefer Acme toothpaste is 0.8 plus or minus 0.025. All right. That's the kind of thing that you're going to be looking at. All right. I'm going to go ahead and throw the formulas at you. Understand that the calculator is going to do most of the heavy lifting as far as the calculations are concerned. Okay, so just to go back over this, right? Every confidence ever is point estimate plus or minus some kind of margin of error. Okay, now in this case, our point estimate is going to be called p hat. Okay, that's how you pronounce this guy. It's called p hat. Right? And that's going to be plus or minus. All right, and then we still use the same confidence coefficient. We're still using z. Okay, so we use sigma known, we use z. Sigma unknown, we use t. That's the one that's different. And then back to where we are with proportions, we're back to using z again. All proportions use z. You don't have to look up degrees of freedom or anything like that. So plus or minus z, and then we have a big square root, okay? And then we have p hat 1 minus p hat all divided by n. Right? This is a kind of a difficult thing for a lot of students to calculate. This one advantage of going with the calculator is that you're not under the gun to do this anymore. Your book recommends 3 decimal places. If you actually had to do these calculations, I would say 6, because these numbers are usually very small. There's a lot of round off error that can happen here, and when you take the square root, it gets to be kind of a mess if you only deal with 3. Okay, we can report to 3. Our answer will look like 3, but when you're doing your intermediate calculations here, I would say 6 at a minimum. All right. So what we really care about here is, well, I want you to be able to calculate this, but we'll do an example in a moment. Okay. What we're going to do here is we're going to check some assumptions, because that's kind of an important thing for this section. Right? So we have some assumptions to deal with. The first 2 deal with independence. So every confidence interval wants to pull this thing up as a random sample. Okay, so that's part of it. You can't just take well, I like these best 3 out of 5. We'll take them. Like, no, you can't do that. You got to go with random. Okay. This is something that if I'm going to ask you a question about this, I will try to telegraph this as much as possible because I really want you to check the assumptions. That's what it'll say, like check the assumptions to make sure it's right. But the population is at least 20 times larger than your sample. Okay? That means that we need that for independence, okay? But that means that you can't take something that has a population that might be so small and then say, well, I'm going to pick 30 of these people. Like, well, there's only 600 of this in the world. You're not, it's a good chance that those 600 people might actually know each other. Those 600 things might be related. So that kills your independence. Again, if there is ever a question, they should be telegraphing this from a mile away. Like you should be able to see, like, hey, we're looking for one-eyed sparrows that favor their left wing, but they had to have only been born on Galapagos or something. Okay, they're going to minimize all of this down so far that it's going to be like, I wonder what they're getting at here. That's what they're getting at. All right. 3, your items are divided into 2 categories. Okay, into 2 categories. And this is intro to statistics here. Could you imagine, I mean, people do problems where they use the trinomial where you can put things into 3 things, but in order to keep things kind of easy, we just use married, not married. We don't deal with all of the different possibilities there are. Okay, so we don't deal with that. Okay, and then your sample has to have at least 10 in each. Really, what you're looking for is this has to be true and this has to be true. Okay, your n times p has to be bigger than 10. Your n times 1 minus p has to be bigger than 10. Really, what they're saying is it has to be 10 in each category here. All right, we do that, and let me go ahead and turn the page, and I'll show you why we're doing that. Okay, so the reason why we do that, so np must be bigger than 10, and 1 minus p must be bigger than 10. Your book is actually rather conservative when it comes to this. A lot of books use 5. Okay, so this was kind of an arbitrary choice here, but they went with 10. We're going with 10. That's the rules. Okay, so if you don't have a 10, we are using a z distribution here, right? And our proportion is kind of stuck between 0 and 1. And if this is not bigger than 10 or this is not bigger than 10, what happens is instead of getting some kind of a proportion, which you're looking at that, right? There's your p hat, and it can lie on either side, and we're kind of looking at like, where is this thing? What happens here is that you end up with something that kind of gets scrunched up against an edge. You're like, oh, there's my normal distribution. That's not exactly normal. It's kind of squished here, okay? Or you might end up with something that doesn't even make it to a peak, okay, if it's really tiny. So when you have your proportions that are very, 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 very small or very, 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 very large, you're ending up with something that looks like this in here for the shape of your p hat, and you want to avoid that as much as possible. Okay, so like I said, the book says we're going to go with 3 decimal places in your answer. Okay, in general, your homework should guide you. Okay, on that one, and I'm going to go ahead and halt the first video here, and then we're going to do an example in the second video. All right, thank you.